everybody. What we're going to do now is we're going to look at the second half of hydrolysis, and we're going to look at what happens with some more acidic base, some more acidic compounds and things like that. Now, the before we looked at the very basic of neutral salt and how do we know if it's neutral, like sodium chloride, because those are both from strong acids and strong bases. And then we looked at when one was a strong acid or one was a strong base. So, and that's what we looked at for yesterday's notes. So today we're going to look at the second part of acidic acids, or acidic salt, sorry. Acidic acids, acidic salts. So salts that contain an anion of a strong acid and a highly charged metal cation. So these are very specific ones with where the cations have like a 3+ charge. So like chromium, aluminum, and iron are the ones you're going to see specifically. So I'm going to be very specific about that. So you guys see either chromium or aluminum or iron, and it's going to be in this sort of compound here. So these cations produce an acidic solution because the hydroxide cation acts as a weak acid. Okay, so what mass of chromium chloride, chromium 3 chloride, will produce a pH of 2.75 and 250 mL of water? So first off, you need to understand that chromium chloride, the chloride will not hydrolyze because it's chloride, and it came from HCl, right? The chromium is going to make this compound here. So this piece here you have to know. So anytime you see Cr3+, Al3+, or Fe3+, it's going to be mixed with this H2O 6+ with a 3+ charge. So first off, we're going to find the concentration of the hydronium ion, which we know what the pH is. So what we can do is we can get the concentration. I don't know what the original concentration is, but I know what the change is. Okay, I know what this change in pH is going to be because that's that concentration of the hydronium ion. I know this is going to be 0 at the beginning. I don't know what the initial is. And you can usually get that from the question because they'll say what mass or what concentration. So you'll know it's this initial right here. I know what my Ka is for my charts. I can let X's be here. And then when I've found this obviously will be my negative and this will be my plus. Simple ice charts. So when I work through this, I'm going to get my Ka. So I know what my Ka is. I don't know what my concentration of my, I do know what my concentration of this is. I do know what my concentration of this is, and I do know what this is. Okay, so here, this is the X, this guy here is this one, and this one is just squared because these are the same things. Okay, and so what I get is my concentration, and then I multiplied by the molar mass. Now, this is going to be the molar mass of, because it asked you for the CrCl3, or CrCl3, so the chromium 3 chloride. This is going to be the mass of the chromium 3 chloride. Even though this is the concentration of this, we're looking at the concentration of the chromium. So I'm going to multiply that by the molar mass, and therefore I'm going to get my mass of my chromium chloride. Okay, it's a big step problem, and this is some complex sort of problems here. Type 5, these ones I'm not really worried about you knowing how to do the reactions for, but there's certain weak acids and weak bases that won't hydrolyze. Okay, so salts that contain weak ions they're both weak, so weak acid ions and weak base ions, they won't hydrolyze. Okay, so but what we're going to do here, salts that contain, let me go back to that. Salts that contain weak acids and weak ions, partly they won't hydrolyze because they'll generally have like sodium or something like that in them. Okay, so I got sodium chloride here and ammonium cyanide. So here, this gives me a Kb or a Ka, and here's my Kb. If the Kb is larger than the Ka, it's going to be a basic solution. And then salts that contain the cation of a strong base and an amphiprotic anion. So those, remember those amphiprotics, so they can either accept or donate a proton. Okay, so you gotta be aware of those guys here. They're generally these two and water. Okay, so you'll just want to compare your Kb and Ka of these two, just like you did up in type 5, and see which one's larger. And whichever one is larger, that will tell you if it's acidic or basic. There's a nice table on page 299 of 5.1.1 which will sort of help you sort of go through this. But it's just working through these problems, and it's just going back to what we looked at in the last class, with just recognizing. It's so much of this stuff is just recognizing, does it does it hydrolyze or not? And if it does, then you go into your ice chart. If it doesn't, you just ignore it. So it looks way more complicated than it actually is. So these guys here, you don't have to do calculations for. You will for this one, but not these guys here, because you're just going to basically compare the Ka and Kb. So you're not going to be doing ice charts for this sort of stuff. Anyways, I hope you have a great day, and we'll talk to you soon. Bye-bye.